Hello, everyone. Today we are on example 1 and lesson 2-2 in your workbooks. It is page 96 for honors. Your page number will be different, so listen to what your sub is telling you. But let's look at example 1. It says, Sergio is training for a triathlon. His target speed is 25 miles per hour. Did he achieve his target speed for the first 7 miles of his ride? So, I need to figure out the unit rate, which we talked about yesterday, to figure out how many miles he goes per 1 hour, because I'm given that his target speed is 25 miles per hour. So I need to see if he keeps up this pace, is he going to go 25 miles per hour? So I'm going to start by making my chart. Every time we do this, our chart, we are going to label it for this is miles and this is hours. And we know he goes 7 miles in 15 minutes. We also know the relationship. There is 60 minutes in an hour. And I'm trying to figure out what 15 minutes is. So I do 60 divided by 15 minutes. And that gets me 1/4 of an hour. So then he's going 7 miles in 1/4 of an hour. Now I need to figure out how much he goes in 1 hour. My 1 is staying with my hour, trying to figure out how much he's going in 1 hour. So the relationship from 1/4 to 1, to get to 1, I need to do 1/4 times 4, which gives me 1. Whatever I do to my hours, I also have to do to my miles. So I need to times by 4 here, and we know 7 times 4 is 28. So this is telling me he's going 28 miles per hour. His target speed was 25 miles per hour. So he's going more, 28 is larger than 25. He's going more miles per hour, so he did achieve his target speed. Now we're going to look at our try it. What I need to know here, see, they made our chart miles in our hours, and then they already told us the relationship between 1/4 and 1. I'm dividing by 4. I need to go from, because I know it's giving me 30 miles per hour, putting my 30 here, because that's for 1 hour. Now I need to figure out 1 divided by what gives me 1/4, which is 4. That's on the top and the bottom. Okay, now I want you guys to solve this. And we decided that 30 divided by 4 was 7.5. So Sergio must ride 7.5 miles in 1/4 of an hour to achieve his target goal. Now let's look at example 2. Example 2, we are using a unit rate, so it's we're finding and applying a unit rate involving fractions. So example 2 says Bronwyn mows the lawn every other weekend. She mows 12,000 feet squared in 2/3 of an hour. The lawn is 36,000 feet squared. So I'm trying to figure out how long it takes her to mow the entire lawn. So first of all, we're creating our chart. The area, which is our feet squared, and then hours, and we're going to make our chart. It tells us that she mows 12,000 feet squared in 2/3 of an hour, and I am trying to figure out my unit rate, so how much she mows in 1 hour. So then I need to do 2/3, and then the relationship from 2/3 to get to 1 is I need to multiply by the reciprocal, which is 3/2. Whatever I do to one side, I've got to do to the other. So 3/2. Now, 12,000 times 3/2. You guys can type that into your calculator, and you get 18,000. So I know it takes her 1 hour to mow 18,000 feet squared. But what am I trying to figure out? My lawn is 36,000 feet squared. So I need to figure out the relationship between 18,000 and 36,000. So 36,000 divided by 18 is 2. So I need to do 18 times 2 to get me to 36. Whatever I do to my top area, I've got to do to my bottom. So I need to multiply that by 2. And 1 times 2 is 2. So it takes her 2 hours to mow 36,000 feet squared. So I used my unit rate. I figured out my unit rate first, and then I used that to figure out what it would be for 36,000 feet. Now, I want you guys to do your try it. So it says every other weekend, Rowan's brother Daniel mows the lawn. He mows 15 feet squared in 3/4 of an hour. Who mows the lawn in less time? So we're setting up our chart again and then finding our unit rate. Okay, so let's set up our chart. I have my area and then my time, which is hours. And I know, sorry, this is really crooked. I know that he can mow 15,000 feet squared in 3/4 of an hour. And I'm trying to figure out for 1 hour. So I do 3/4, the relationship between 3/4 and 1. 1 divided by 3/4 is 4/3. So I'm multiplying both sides by 4/3. The top and the bottom, you can't really see what I'm writing there, but 4/3. And then I'm going to do 15,000 times 4/3, which gives me 20,000. Now, that means that Daniel mows 20,000 feet squared per hour. So for 1 hour. I should have put my feet squared there, sorry. For 1 hour. And we know that Browen mowed 18,000 feet squared for 1 hour. So 20,000 is larger. So Daniel mows more per hour than Browen. Okay. And last but not least, let's look at example 3. Okay, so now we're looking at example 3. We're solving problems using unit rate. First of all, I want to look at this image. This is a map, and it's a scale drawing. So what I'm trying to figure out is what the actual distance is between these things. So it says Omar knows his friend Chris lives 3/5 miles away. So Chris to Omar's house is 3/5 miles away. But on our map, it is 3/5 miles is 3/4 of an inch. So I need to write my graph because I'm trying to figure out, not hours. I'm trying to figure out what the actual distance is. So I have miles, 3/5 of a mile is 3/4 of an inch. And I need to figure out what 1 inch is. I'm trying to figure out my unit rate. So I need to figure out what 1 inch is. So the relationship between 3/4 and 1 inch is I've got to do 3/4 times 4/3 to get me to 1 inch. Whatever I do to the top, I've got to do to the bottom. Or vice versa, whatever I do to the bottom, I have to do to the top. So I need to multiply the miles by 4/3. So 3/5 miles times 4/3 miles gives me 4/5 miles. So now I just figured out that on my chart, 4/5 miles is 1 inch. Now I'm trying to figure out how far the school is from Omar's house. So I'm given 2 inches. So Omar's house is 2 inches away from the school. But I only know that 4/5 of a mile is 1 inch. So I'm going to make a new chart. And I have my miles and my inches. Oop, I spelled inches wrong. And what did I just figure out? That 4/5 of a mile is 1 inch. And Omar's house is 2 inches. So I've got to figure out what it is for 2 inches. Oh, can you see that? So then 1 times what gives me 2? I've got to multiply by 2 on both sides. And then 4/5 times 2 gives me 8/5 miles. So I have found out that Omar's house is 8/5 miles from the school in real distance. I can also take my 8/5, and 8 goes into 5 one time, so I have a whole. Subtract 5 there, and I've got 1 3/5 miles. So, relating it back to the problem, Omar's house is 1 3/5 miles away from the school. Now, I want you guys to do your try it. Okay, Sonoma bikes 5 miles to Paige's house. On a map, they measure that distance as 5/6 of a centimeter. So 5 miles, I'm just going to write it off, equals 5/6 of a centimeter. I know that I'm going to be making my chart. 5 miles and centimeters. 5 miles is 5/6 centimeters. The same map shows that the mall is 3 1/2 centimeters from Paige's house. What is the actual distance between Paige's house and the mall? So first of all, just like all the other problems, I have to figure out my unit rate. So I'm trying to figure out for 1 centimeter. What I need to do on both sides, 5/6, and I've got to multiply by 6/6 to give me that. So now I have 1 centimeter. Oops, sorry, I'm not multiplying by 6/5. I'm multiplying by 5/6. Sorry. Need to multiply both by 5/6. And 5 times 5/6 gives me 6. So we just found out that 6 miles is 1 centimeter. So I'm going to write off to the side. 6 miles is 1 centimeter. So I'm going to make my new chart. Miles to centimeters. And then I just found out my unit rate. 6 miles is 1 centimeter. And I want to figure out 3 1/2 centimeter because that's how far away the mall is from Paige's house. So I need to do 1 times 3 1/2 on both sides, and 6 times 3 1/2 gives me 21. So I just found out that the actual distance from Paige's house to the mall is 21 miles. Now, I want you guys to answer questions 7, 8, 9, 10, 11, and 12. If you have any questions, ask the sub or whoever's in your classroom, and I'm sure they would be glad to help. After you are done with this, log on to iReady and start your iReady time. Have a great rest of your day.